Hi everyone, I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In the last video, we have discussed exact equations. What is an exact equation and how to find the solution of the given exact equation that we have seen in the last video, and we have done some problems in the video. Now, in this session, I am going to explain the non-exact equations, solutions of non-exact equations, how to find the solutions of the non-exact equations. If the given equation is non-exact equation and we can make it exact by using the integrating factor. So the title is equations reducible to exact form. So before reducing the exact form, we see one definition, integrating factor. What is an integrating factor? Suppose if mdx plus ndy is equal to 0 be not an exact equation, is equal to 0 be not an exact equation, and if mdx plus ndy is equal to 0 can be made exact by multiplying it with a suitable function mu of xy not equal to 0, then mu of xy is called an integrating factor of mdx plus ndy is equal to 0, where m and n are functions of x and y. Suppose if it is exact, then we can find the solution by using integral mdx plus integral the terms of n not containing x terms into dy is equal to c. Suppose if the equation is not exact equation, so how to make it exact? That can be done by using the integrating factors. So what is an integrating factor? If mdx plus ndy is equal to 0 is not an exact equation, and the equation mdx plus ndy is equal to 0 can be made exact by multiplying it with a suitable function mu of xy, then mu of xy is called an integrating factor. So after getting integrating factor, we multiply it with mdx plus ndy is equal to 0, then the equation will be an exact equation, and the solution we can find. How to find the solution? By previous method we know that, and we follow the same procedure. So here we study 4-5 methods of finding integrating factors based on the given equation. So now I am going for type 1. Suppose if mdx plus ndy is equal to 0 is not an exact equation and it is a homogeneous differential equation. Homogeneous means already we know that. Homogeneous means if the given equation in the terms are having equal degree, then we say that it is a homogeneous differential equation. Or we say that if dy by dx is equal to f of xy is a homogeneous differential equation, if it is a homogeneous function of degree 0, then we say that it is a homogeneous differential equation. Suppose if mdx plus ndy not equal to is equal to 0 is not an exact equation, and moreover it is a homogeneous differential equation, and mx plus ny not equal to 0, then the integrating factor will be 1 by mx plus ny. So this is the type 1. So if mdx plus ndy is equal to 0 is not an exact equation, and moreover it is a homogeneous equation with mx plus ny not equal to 0, then 1 by mx plus ny is the integrating factor. So after getting integrating factor, we multiply with mdx plus ny is equal to 0, and the equation will become exact equation, and then find the solution by previous method only. So we see some problems how to find the solution of the given problem non-exact equation. Solve the differential equation x square y dx minus of x cube plus y cube of dy is equal to 0. So you can say that it is a first order and first degree differential equation. So to check whether it is exact or not, we go for the condition for exactness, that is whether dou m by dou y is equal to dou n by dou x or not. That we have to check it out first. So given m dx, what is m here? X square y, and n minus of x cube plus y cube. Then what is dou m by dou y? The partial derivative of m with respect to y. So when we are doing partial derivative with respect to y, x terms treat as constant. So x square as it is x square, and y become 1, the value is x square. Similarly, dou n by dou x. When you are doing partial derivative with respect to x, y term treat as constant. The second term will be 0. Only the first term derivative, that is minus 3x square. So clearly you can observe that these two are not equal. One is x square and other one is minus 3x square. Therefore what? The condition fails, exact condition fails. So it is not an exact equation. Then, and also you can assume that you can see that here x square y, it is a x square y 3 degree dx minus x cube plus y cube, it is also 3 degree of dy is equal to 0. That means it is a homogeneous differential equation. Homogeneous differential equation. So our condition satisfy first type 1. Then we have to check for mx plus ny value. And equation 1 is a homogeneous equation in x and y. And we check mx plus ny. So m is x square y into x minus of x cube plus y cube of y. So on simplifying you get minus y power 4. So clearly it is a non-zero element. So therefore what is integrating factor? 1 by mx plus ny as per our type 1. That means minus 1 by y power 4 is the integrating factor of the mdx plus ndy is equal to 0. That means given equation. So after getting integrating factor, what to do? We have to multiply this with equation 1. What is equation 1? This is equation 1. The given equation is x square y dx minus of x cube plus y cube of dy is equal to 0 is the given equation. We multiply this with the integrating factor. Then we will get minus x square y by y power 4 dx plus x cube plus y cube minus y power 4. Already minus sign is there. Minus 1 by y power 4 and multiplying it 1 by y power 4 dy is equal to 0. Now, this is an exact equation. You need not to check. This is an exact equation. And the general solution will be integral m dx. Here m is this is. Here n is this is. Here m dx taking y as constant plus n dy not containing x terms is equal to c is the solution. So on seeing this, we will get integral x term minus x square by y by minus x square y by y power 4. So y cancel, minus x square by y cube, that is the term. So this is minus x square by y cube dx. Here x term should not allowed. That means x cube by y power 4 is not allowed, plus y cube by, this is x cube plus y cube by y power 4. That means what? X cube by y power 4 plus y cube by y power 4, that is 1 by y. This is containing x terms and this is not containing any x term. So we have to omit this term. We have to omit x cube y by y power 4. So the remaining term we write it is 1 by y. Am I right? 1 by y only, second term. That I write here integral 1 by y dy is equal to c. So what is the integration? X square integration. Integral x square dx is equal to x cube by 3. So already minus sign is there. Y cube constant minus x cube by 3y cube plus integral 1 by y dy, that is log y is equal to c is the required solution of the given equation. So if the given equation is not an exact equation and if it is in the homogeneous equation form, then mx plus ny, see the value, if it is non-zero, then 1 by mx plus ny is the integrating factor, and multiply with 1 by mx plus ny and integrate, then the equation will become exact equation and find the solution as usual, right? Now we see one example. So solve the equation y square dx plus x square minus xy minus y square dy is equal to 0. So this is also in the form m dx plus n dy is equal to 0. So in the first step we have to check whether it is an exact equation or not. If it is exact, then we write solution as usual. If it is not exact, we made it exact by using integrating factors. So what is here m? M is equal to y square. Here m is equal to y square. And what is n? N is equal to x square minus xy by y minus y square. Then we are finding dou m by dou y, that is equal to 2y, and dou n by dou x. So this is 2x and this is minus y only, and this is 0 because it is y term, it is treating as constant term. So the derivative is 0. So here x is 1, y will be constant. So 2x minus y, and these two are not equal. That means what? The equation is not an exact equation. And moreover, you can say that the equation 1 is a homogeneous differential equation because dx coefficient is 2-degree function, dy coefficient also 2-degree function. So it is a homogeneous differential equation. And also we have to check mx plus ny value, mx plus ny. So here m is y square into x plus n means x square minus xy minus y square into y. That is xy square plus x square y minus xy square minus y cube. So then what is the terms gets cancelled here? Xy square and xy square, or y are taking outside, x square minus y square, which is not equal to 0. So it is not a exact equation, and the equation is a homogeneous differential equation, and mx plus ny not equal to 0, then we can decide that the integrating factor will be 1 by mx plus ny. So what is mx plus ny? 1 by y into x square minus y square. This is the integrating factor, and call this is equation number 2. Now, to make the equation 1 as an exact equation, we multiply 1 with 2. So then what will happen? On multiplying equation 1 with 2, y square, then 1 implies, equation 1 implies y square dx by y into x square minus y square. First term. Second term, x square minus y square minus xy by y into x square minus y square of dy is equal to 0. So now this equation is exact, no need of checking. So it is not exact equation, and it is a homogeneous differential equation. The mx plus ny not equal to 0. Then as per our theorem or type 1, 1 by mx plus ny is an integrating factor. So on multiplying the integrating factor with equation 1, the equation 1 will become exact equation. So this equation can be rewrite. And how I can write? I will show. So how I write, y gets cancelled. Here I will remove. And what is the value here? Then what we will get? Y by x square minus y square into dx. First term. Second term, x square minus y square by x square minus y square gets cancelled. First term 1 by y. And what is the second term? Minus xy by this term. Y cancel. X by x square minus y square of dy is equal to 0. Just I have simplified the equation. Then you will get, on rewriting, you will get this one. Now, this is an exact equation, and the solution will be in the form, the general solution, the solution will be integral y by x square minus y square dx plus integral the terms of n not containing x terms, and we should omit the second term. Only we will get the first term 1 by y dy is equal to log c. I hope this is clear. Then the function y into, so what is 1 by x square minus a square integration? That is 1 by 2y. I will write 1 by 2y into log x minus y by x plus y. This is the integration plus log y is equal to log c. So y gets cancelled and log x minus y whole power 1 by 2. I'm writing here. This is log m plus log n, and log m into n. Y into x minus y by x plus y whole power 1 by 2 is equal to log c. Or deleting log both sides, y into x minus y whole power half is equal to c into x plus y whole power 1 by 2, which is the required solution of the given differential equation. Similarly, we do another problem. Solve the differential equation 3xy square minus y cube of dx minus of 2x square y minus xy square dy is equal to 0. So I will solve this equation also in the same procedure. Here what is m? What is m? 3xy square minus y cube. And what is n? What is n? So on multiplying with minus sign, I rewrite xy square minus 2x square y, m dx plus n dy. So n will be minus of this one, or on multiplying with minus sign, xy square minus 2x square y. So now we check the condition of exactness, dou m by dou y. What is dou m by dou y? And differentiating partially with respect to y square derivative 2y, 3x is constant, that will be 6xy first term, minus y cube, that is 3y square. Similarly, dou n by dou x, so the partial derivative of n with respect to x only, that is x1, and this becomes y square minus, so 4 into xy. Clearly, these two are not equal. So the equation is not an exact equation. The equation is not an exact equation. Then what to do? And moreover, this is a homogeneous differential equation because each term having degree 3. This is y cube degree 3. This is x square y. This is also 2 x power 2 y power 1. So 2 plus 1 degree 3. xy square, that is also degree 3. That means it is a homogeneous. It is a homogeneous differential equation. And now we have to check mx plus ny value. What is mx plus ny? M means 3xy square minus y cube of x plus n means what? xy square minus 2x square y of y. Then it is 3x square y square minus y cube x plus xy cube minus 2x square y square. So what will get? These two will get cancelled. Xy cube will get cancelled, and this is equal to 3x square minus 2x square y square. 3x square y square minus 2x square y square, that is x square into y square, which is not equal to 0. Therefore, what will be the integrating factor? 1 by mx plus ny is an integrating factor. That means what? 1 by x square into y square is the integrating factor. So after getting integrating factor, we have to multiply this with equation number 1 so that the equation 1 will be exact equation. So on multiplying, equation 1 implies 3xy square minus y cube of dx by x square y square minus 2x cube, x cube or x square I think, x square y minus xy square dy by x square y square is equal to 0. So on simplifying, what you will get? xy square gets cancelled. You will get first term 3 by x. Second term y cube y square will get cancelled. Y by x square of dx, that is the first term. 3x y square by x square y square. So y square cancel and x cancel. 3 by x first term. Second term y square cancel, y by x square of dx minus second term 2x square y by x square x square cancel. This is only 2 by y. And what is the second term? xy square. This is also xy square, x square y square. You will get 1 by x of dy is equal to 0. And moreover, it is an exact equation. So exact means we can write the solution directly. So what is the solution? Integral m1 dx. That means what? 3 by x dx. That is the first term. Second term minus y by x square into dx. Second term. Third term minus integral 2 by y dy is equal to c. Right? So on integrating, what you will get? 3 log x, the first term. 3 into 1 by x dx, log x, 3 log x. So second term, y into 1 by x square dx, integral 1 by x square dx. That means what? X power minus 2 plus 1 by minus 2 plus 1. That means minus 1 by x. Am I right? X power minus 2 plus 1 by minus 2 plus 1. So this is 1 y means y by 1 by x means plus 1 y by x, and minus 2 log y is equal to c. This is the solution of the given non-exact differential equation. If it is not exact, we made it exact by equation, by using integrating factor equation 2. Then the equation reduced to this form and it is exact equation. So after getting exact equation, we solve this equation by using the procedure of finding the solution of exact differential equation. So on solving this equation, we will get the required solution of the given equation number 1. So this is the type 1, when the equation is not exact equation and the equation can be made exact by using integrating factors, and integrating factors can be found by using the nature of the given differential equation. Here 1 by mx plus ny is the integrating factor. So after getting integrating factor, we multiply it with the original equation so that the equation will become exact equation. So similarly, we have another 3 methods to find the integrating factors. In the next session, I will go for the type 2 integrating factor method of solution. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.